Okay, so let's start. So we'll work on the product class. We'll kind of talk about the instance variables, see what ones could be there and are missing, talk about exceptions. And if you remember, we had, we had written a class called my exception also, and I'll open up that class too. And of course, we were doing things in the tester, which we'll kind of talk about. Okay, so the aim is to talk about today new, or maybe something you forgot, and we'll revise our exceptions. Okay, so now the class says, I have these methods. Give me my inputs, give me the parameters. If they're correct and valid, I'll do my job. Else, I throw back an exception at whoever calls me. And that's very common. It's a common practice. If you notice in your Java code, in your Java, wherever, any class that you pick up, something that you're familiar with, let's pick up, say, string. Let's pick up a string class because you're familiar. You should be familiar with the array list also now. So let's pick up the string class and you click on any method. So there are constructors and methods. So let's kind of just say character at the first method itself. Notice how it has a throws now. Maybe you haven't paid a lot of attention to it, but methods in Java classes throw exceptions. Throw exception means it wasn't able to do what you asked it to do. Now, some exceptions are unchecked. They are thrown. You don't do anything about them. The Java runtime unit will do something about it. And what does it do? It will give you those error messages and in all that red and say, this is where the error occurred, so on and so forth. So if you try to do something division by 0, it comes up with that error. And the program stops execution, right? If you try to do arrays out of bound, you go try to access an element below 0 greater than your maximum size, it will again say arrays out of bound index and it will stop. So abnormally terminates. That's again what you are going to do. You're going to write your classes, your methods. If you give them valid values to work with, they will work, else they will throw an exception. That's it and stop. And then now when you write your testers or your applications, you will either catch those exceptions by try-catch blocks. If you remember, we'll talk about it again. You will catch those exceptions and say, okay, this is how I want to handle it. So if you're giving me an exception back, I'll show it on the screen, neat and clean, and then terminate the program. So either you handle them or you let the JRE handle them. And how does JRE handle them? We all know it. All those red error messages on the screen, which we don't like. So you will learn both. Classes will throw exceptions and your testers, which are your applications, will handle those exceptions. So we'll learn to do both of them. Okay. So as you see, what happens? Why this character at throws an index out of bound exception? Suppose I'm asking in a string, what is the character at position -5? Is that possible? No. What is if the string length is 10, I'm saying what is the character at position 15? Is that possible? No. So if you try to do something that is not possible, the method just throws an exception to you and the program stops execution. You're now going to take the same approach. You are going to write methods that if the input is valid, you will do the job, the method will do its job, else it will throw an exception. That's what we are going to learn. And then step number 2, we will learn how to handle these exceptions in the tester. You should know that too. Okay. So now in Java, the exception class is of course, you have the throwable class and then exception class inherits from it. And the exceptions are divided into 2 categories, checked and unchecked. Unchecked, you can ignore. And anything that belongs to the runtime exception and any of its subclasses are unchecked. So index out of bounds, division by 0, all these are unchecked. Therefore, you don't have to do anything about them. Nothing happens. No compilation errors, nothing. When you run them, you get a runtime error. On the other hand, checked exceptions have to be handled in your code. So you've never yet written or come across checked exceptions. Otherwise, your code will not even compile. Any checked exception has to be handled in the code. So we haven't used any. Now, what kind of exceptions will we create? We'll keep to the unchecked side. Because the checked ones are very system dependent. Therefore, they're checked. They have to be taken care of. Quite complicated. Okay. We've only encountered very uncomplicated errors till now. So job number 1. We will decide what method, if it doesn't work, will throw an exception. 2, will we use exception classes of the Java class or will we create our own exceptions? You can do whatever. You can say throw new exception. An exception is the class, it will just work. Or you can create your own exception class called say my exception or quantity exception, price exception. So your classes are more defined and you will say this is what I want to do. To keep it simple, what I've done is I've created my own exception class just so that it's called something else rather than exception. I've said my exception. and it has extended the exception class. So I am still using the exception class as the base. Inheritance, extends is inheritance. I can't create an exception class without inheriting. I have to have a base. For all other classes you've created till now, clubs and memberships and calculators, you didn't need any inheritance. They were just independent applications. But exceptions, you have to have some father, right? So what have I done? I've created an exception class called my exception that extends from the exception. So I'm saying, okay, give me everything you have and I'll do whatever I need more. I don't have much more. What have I done? I've created my constructor. And in the constructor, I've just asked the help of the exceptions constructor. Therefore, super is a call. Super says, call the super constructor. And who's your super class? Exception. And you've passed a message to it. So which constructor are you calling of the exception class? One that takes a message. Once it has the message, you can print it out wherever you want. Right? So I've done the easiest way of defining an exception class. Extends exception. The constructor calls the super. Then what's the advantage? You'll say, what's the advantage? These messages are the advantage. I can now give user-defined message. Price cannot be negative. Quantity must be greater than 0. These messages are not available in the exception class. They're not. So all I did was create an exception class, which does nothing extra. Same as exception. Extends it so I can use all its properties. And the first statement in the constructor body of a derived class, this class is derived now, or we also in Java it is called a subclass. In C++ or C#, we call it a derived class, right? And this class is called the super class or the parent class, right? So all I've done in my subclass is the constructor calls the super constructor and passes the message to it. With this, the advantage is that in my catch blocks, when I handle these exceptions, I can always get this message because there is a get message method in the exception class. That's all is the advantage. So the advantage is user-defined error messages. Very important, right? And 2, displaying the messages when I handle them. That's the main aim. So it's as simple as extends and do it. Another thing that you should know in inheritance is when a class extends from another class, then the first statement in the constructor body of the subclass has to be a call to the super constructor. It is a requirement. It has to be a call. So if there is a super constructor that does not take a string, I can even do it this way. This is working too. So that means exception class has 2 constructors for sure. One that takes nothing and one that takes a string. I definitely know it because both are working. But this one is useless because what's the use of a message if I can't show it? The whole purpose of creating my exception class is to show messages, relevant messages on the screen. So I'll stick with this one. So I'll call the super constructor. So if your super class has more than 1 constructors, whichever you want, right? Whichever works for you. So for me, this one is working where I pass it a message because I will be able to get this message out of the exception object when I need to print it. Okay. So there is my simple exception class. I've called it my exception. That's it. Now let's look at the product class. I decided to have 4 instance variables in my class. The ID of the product, which will be unique. The name, which may not be unique, right? I could have bolt, 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 4 bolts because their IDs are different. Their description could be different. Their manufacturer could be different, whatever. But names may not be unique. I'm calling, they could all be bolt. So I could have more than 1 type of bolts or nuts or whatever, or mouse even, right? So let's stick to our terminology. So I could have, the product name is mouse. The description, which I don't have, could have, say something like, Microsoft mouse, whatever, 2 buttons, 3 buttons, whatever. So the ID will be unique. So that means every product is identified by its ID. The name may or may not be unique. So you can add it here, may not be unique. So I may ask you, can you show me all the products by the same name? Then you can do a for loop, for each loop, compare the names and give me a list, right? So therefore I'm saying not unique. The quantity, how many in stock, right? So why is this quantity important of a product? Because ultimately I'm going to use this product object in an inventory, and an inventory you always have some quantity, right? So therefore I'm keeping this quantity. For a product, it may not seem so useful. Product quantity doesn't make sense. But if you kind of think of it, even if you're talking a retail shop, there is always a quantity of a product. You know what I mean? So I've chosen quantity to be an instance variable, and of course every product will have a price. You could choose double. I've chosen fruit. Anything will do. What other instance variables do you think you can add to a product class if this product class was part of an inventory? What do you think? When you think of, you know what inventory is? Where you stock products, right? Like even retail shops have inventory. They have to keep something in inventory. What other instance variables, and let me be very specific to its quantity, do you think I should add or could be added in this class? So there is a quantity of a product. Does a product always have a maximum quantity it can be stocked to? Yes, you can't stock beyond a quantity. Otherwise, how will they manage their quantities? That's why we have all these sales, because when there is a seasonal change or something, they want to get rid of the previous so that they can get in new, and there is always a limit. If you have 10 boxes, how can you keep 12 things? So I could add another instance variables called maximum quantity to this instance variable. And that's a valid one in inventory. Have you heard of reorder level? So there is something in inventory and now you are selling. When it reaches a particular level, like 5 or 6 or whatever, depends upon, then it has to be ordered again, right? So suppose Walmart is selling some, I don't know, bicycles, and it says we'll keep 10 in stock. It's more than enough. But when I've sold and the stock reaches 2, I have to reorder again because I need to reorder again. Of course, if it is summer, right? So that's called the reorder level. So another two variables, instance variables that you could add to this list and you will be adding in your in-class assignment are maximum quantity, till where can you order? That's it. You can't stock beyond it. And a reorder level, which will say if the quantity goes below this, I need to reorder. And a reorder Boolean variable, which will be true or false depending upon does it need reordering or doesn't. So is quantity less than the reorder level. So these three new variables I will leave to you to add when required. I'll try to complete this code. Okay. So let's look at the constructor. Job of the constructor to set the instance variables with values that are logical, right? So I take an ID, this product constructor takes an ID and calls the set ID method to set this ID. So let's look at the set method right there. What does the set method do? Whatever is coming to, this is the get. Oh, there are all gets. Okay, so the set ID method somewhere, come on, there, right? So takes an ID from you, doesn't matter what you call it, and assigns the ID that was given as a parameter to the ID of the class. So now when the name of the parameter is the same as the name of the instance variable, start using this with the instance variable. Otherwise, it will mean the local variable. It just looks, oh, ID, what's nearest to me? This is nearest to me. What is nearest to this statement? This statement. So it says, oh, you're talking about the local ID, local variable. That's not what I'm talking about. I'm saying take the local ID and assign it to the ID of the object. Again, this is the current object. Okay, so that's the set ID method. The rest should make sense. Set name is setting the name of the product, set quantity, the quantity, and set price, the price. I could do some checking in ID and names, but they're strings, so I'll keep them alone. Maybe in the next example, we'll not even set the ID. We'll generate an auto ID. We'll do that because that's logical, right? Why should you get an ID from the outside world to set to a product? There should be like an auto increment key that like you have in a database. Maybe we can just take a number like which is a number inside the class and use a create method that creates it and assigns it. So we'll do it in the next example. I won't change this one just because there's an in-class based on it. Now, when is your data for quantity and price valid? Quantity should be greater than 0 and price should be greater than 0. That's the minimum, right? Of course, then if you want, like we don't usually have it, you can say, oh, the price should not go beyond $100 or something like that. But at the minimum, these are the conditions that need to be met in the set quantity method and the set price method. So there are two choices now. Till now, we have been saying if you give the right value, we will use it, else we set it to some default value. Or we leave it alone, we don't do nothing. But now onwards, anytime the input is invalid to a method, the method will throw an exception. That's what the method will do. So let's go to the set quantity or the set price, because it's faster. first. Okay, let me revise this with you because you've forgotten it. And I'll just place it a little differently. You'll see it's just easier to read. Check. If your price is less than or equal to 0, all you do is you throw the exception. Let's see how it is working. I'm just writing this before because it's just take care of errors first and then do whatever. Okay, then I don't need this because if I throw an exception, it absolutely, oh, so you have to return true or false. Okay. Oh, so we'll have to be careful. And now actually the value true and false will not even make sense, because if it is not set, exception is thrown anyway. So now the use of a return Boolean type is useless now, in a sense. You know what I mean? Like you don't need it now. So if you want, I'm not sure. Let me just double check your assignment, and we'll just keep it that way so that there is. I don't know what I did. Okay. So now onwards, since we are kind of changing our attitude or a way of programming, I won't even do this, because you know what? If there is a problem, the program stops anyway. So what is the sense of saying yes, was done, and no, it was not done? Because it is done. If it is done, it is done, and if it is not done, the exception is done. Okay, now let's look at why am I getting an error here. So look at the code first, and then we'll see why am I getting an error. The code is simple. It says if the price value that you give me, we are talking about this price, guys, the local variable. If the price that is supplied to this set price method is either less than or equal to 0, this method is going to throw. So throw is a reserved word. You have throw and throws. Okay, they're two different reserved words. And dealing with exception handling, this method is going to create an object of type myException and throw it back. Will return it. Throw it back means return. Okay, so what does it create? New myException means creates an object of what type? MyException. What does the constructor need from you? A message, a string. Price cannot be 0 or less than 0. Or you can, if you want to complete it, price should be great. Now you can make whatever reasonably sounding error messages. Greater than 0. Cannot be 0 or less. See, what a neat message. So if the user makes a mistake and gives a value that is not valid, this is what will come on the screen. Of course, for now it will be untidy, but we'll learn how to make it tidy. But this is what will happen. I'll show you. I'll create the tester for you in a minute and show you. Okay. But why is it giving a red squiggly? Let's look at it. It says that if this method is going to throw an exception, then in the signatures, you have to tell me. The compiler must know that this method is throwing an exception. All you do is add the throws myException clause in the signature. That's all you have to do. That's a requirement. You are getting a syntax error. So if a method throws an exception, is just throwing it. It's not handling it. It's just saying, oh, problem, here is the problem. So it creates an exception object and returns it to whoever called the method. It's like a return. It is a return, right? It returns it to the whoever is calling that method. It has to, in its signatures, this line is called the signatures. Line 82 is the signatures. It has to mention the clause throws and what kind of exception it throws. You could have even done this because myException is inheriting from exception, but I'll stick to this, right? So if your class had myException, whatever, so many, and they definitely all are inheriting from exception, then I would have said throws exception. Because I can't write throws this, comma, this, comma, this, comma, this. I cannot write. Syntax wise, it's no longer. As simple as that. This is all I've done. I've checked the condition. So I've changed it a little from what we did last week. I've said, let me check what is wrong. And if something is wrong, get it over with. If everything is right at the end, I just assign it. And that's exactly what will happen. Throw means stop. Return and stop. So definitely if this is the problem, it will return with an exception. If there is no problem, it will assign it, and that's exactly what you have to do. So now you've changed your programming a little, in which the method is saying, give me the right data and I'll do my job, otherwise nothing doing. And that's exactly how methods work in Java classes. So exception handling is something that you have to do. You should be doing, except that till now we didn't, because we were just trying step one at a time. But we'll do it. From now onwards, we'll do it in all our classes. Can I do the same in quantity? Let's try. So again, I'll just kind of change the sequence a little. I'll throw an exception, and notice I won't even now say return true or false because it's not, I don't need to. You see, I don't need to now. Oh, but do this, please. I forgot that. Remove the return statement and add the throws clause. So it throws, what does it throw? My exception, right? You name the exception, my exception. If quantity is less than equal to 0. And please make this change in your price also. Remove the return statement. We don't have the return statement anymore. And add the throws statement. So add throws, my exception, if price is less than 0. Less than or equal, we are saying both. Exactly like you see here. See, like here it says throws if the index argument is negative or not less than length of the string. So you will see this kind of, you'll see the same kind of Java documentation when you now create Java doc of your code. You will see it. I can show it to you. I will in Eclipse. Okay. So please do that in the Java documents. Okay. So let's come back to quantity. Okay. So I'm saying if the quantity is less than or equal to 0, do this. And again, cannot be less than 0, or you can say must be greater than 0. So your error messages should be neat, clean, and complete. So I've said both. I've said cannot be, must be greater than 0, cannot be 0 or less than 0. Whatever, like anything that makes complete sense. If everything works, what do I have to do? Just set it. So we are in the set method. So this dot quantity. I'm not sure if, yeah, we call it the same. So this dot quantity is assigned the value quantity. Job done. Now, if you had more than one validations, you can have more than one if statements. That's what you will do. If this, throw this. If this, throw this. If this, throw this. If you're throwing the same kind of exception, my exception, good. Doesn't matter. If you're throwing different kind of exceptions, that will also work. There's nothing wrong in it. But the only thing you have to remember it will go by sequence. If you have the problem in the first if, it will stop right there. If first if is okay and you have the problem in the second if, the first will work, the error message will come from the second one. If the first two are right, the error message will come from third one, and so on and so forth. It's not necessary to throw my exception every time. You could have created two different classes, quantity exception and price exception. And in there, you could have created these messages there instead of creating it here. You could have said throw new quantity exception. Message was already present. You didn't have to do anything, right? But since I'm not creating such a big application, I just created one exception class and I'm passing the error messages from here. But that's not what Java does. Java has its own classes and they have the own exceptions that are handling different things in the classes. Just because we are at stage 1 and Java is mature, okay? So a particular method can throw more than one exceptions. All you have to do is if, throw, and then have a throws clause here. That's it, right? So with exception, if there are different types, with the same my exception if are of the same type, it will stop at the point where it finds an exception. So you may not be able to see the other exceptions, but then if you take care of the first one, then the second one will be thrown if there is an invalid data. If the first two are valid, the third will throw an exception, but it is in sequence.
Can't we throw multiple exceptions?
No, the throw only one throw. Yep, you can only throw one exception object at a time.
If the exception is thrown, the program stops.
Stops. I'll show you. We'll write the tester in a minute.
So we can't continue.
No, you cannot. You cannot. It can be. It said you gave me something. I cannot create the object. Finished. Stop. Right. So in the main, then you'll have to say, oh, exception came back. In the catch, you will maybe ask the user again for the value or something. But here, nothing do. It stops. That's what exceptions do. That's if you try to do division by 0, your program stops. At whatever line you've tried to do a division by 0, program stops. Index out of bound, program stops. That's exactly what happens. Exception thrown and it stops. All you can do is make the exceptions look a little pretty when you put them on the screen. That's all you can do in the handling. Or I mean, that's what it is. What else can you do? If something didn't work, it didn't work.
But the catch block can handle it.
Yeah, maybe. It depends upon what we are trying to write, right? We can do that. So we can have a while loop and we can do that. But right, that's what happens. Thrown and stop. So two things to be remembered. One, a particular method can throw more than one exceptions of the same kind, of different kinds, depending upon, but one throw can only throw one exception object. You can have as many ifs as you want, check everything first, and then at the end, assign. It's just easier, right? That way you're saying, if this, don't do this, if this, don't do this, and so on. And if everything is okay, assign at the end. Different kind of exceptions can be thrown. Same type of exception can be thrown. But when you usually use the same type of exception, your messages will be different. That's how you will know what happened. If every exception had the same message, error, 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 no clue what went wrong. So writing the messages in the exceptions is important because that's how you will know. So I've taken care of my set price and set quantity. Okay, let's look at the other methods, right? So this is all you will need to do. So if I tell you to add a maximum quantity variable and a reorder level variable, and I say these are its valid values, and there are some relations. Reorder level or quantity can never go beyond the quantity, maximum quantity. You cannot go. So you will check that too. So anytime you try to set a value that is invalid, throw an exception and stop. That's all you can do. You have to stop. Exception means something went wrong, and something went wrong means stop. That's exactly what it will do. Let's look at the other methods. The gets and the sets are now done. So I don't think you need anything in the gets to look at. You're kind of familiar with it, right? I've changed the set price and the set quantity by throwing exceptions in both my method and changing their Java doc comments. The toString method is the overridden method. All I have shown is there are these many of this in stock priced at this. A neat thing which shows me what is the ID of the product, what is the name of the product, what is the quantity of the product, and what is the price of the product. That's what it is in toString. I don't think it needs much explanation. Let's now look at restocking. When you restock a product right now, you tell me how much have you bought, and I add it to the previous quantity. That's all. No other check is done because there is nothing to compare with maximum quantity or nothing. Nothing has to be compared. Okay, so let's look restock. What does this method do? It restocks the product with the given amount. That's all it does. So the supplier is buying more to put in the inventory. Okay, so let's look at the method. For now, it is returning a Boolean value. If it works, it will return a true. If it does not work, it will return a false. It takes the amount. It will check if the amount, you can't add a negative number of items to a product or to a stock, to the inventory. So you check if it is greater than 0. And what do? Get the previous quantity, add the amount to it, and put it back. And again, I've said, and I mentioned it again, and I think Michael was the only one, Matthew, sorry, was the only one who kind of also followed it in the exam. Everywhere, whenever he had to talk to an instance variable, he would do a get and a set. Even I got tired of it. Gets and sets everywhere, but that's what it is. So get it, add the amount, and set it back, right? And then return true. Why do you think I'm getting a syntax error here which says unhandled exceptions, though my method is not throwing any exception? Yeah, because you're using a method that is throwing it, and that's rule number 2. If you use a method that throws an exception, the signatures still should have a throws my exception. You could have done something here. You could have done, I haven't done it, but you could have done, if amount is less than or equal to 0, throw my exceptions, amount value should be greater than 0. Another job done. You cannot stock a negative number of value. How will you do it? As simple as this. If, same thing, amount is less than or equal to 0, let's throw an exception. And how do you throw it? You create an exception. You create an exception object of whatever type. I'm sticking again to mine because that's the easiest. Amount to be stocked cannot be, makes sense, right? Cannot be less than or equal to 0. Now my job is done. Now I don't even have to maybe return a true or a false, because if the amount is less than 0, it will stop right there. I can remove this statement altogether. I can remove all this and still do whatever. There, see? Oh, and the type will become void. So this one definitely needs my exception, throws my exception, but the previous one needed it because the method inside it was throwing an exception. So that's another way. How can you stock something if it is negative? You cannot. You could say, can't I do all this checking before I even call this method in the application? Yes, you can do it. Nobody stops you. But the class doesn't know whether the application will do it or not. So it still does it. You know what I mean? Like if you are the programmer, this is your class and you are writing the application, you will take care that the application, the tester, before sending the value, checks it. But what if this is a class in the Java library? You can't force somebody else to write an application that will validate the data and send it to the class. If the Java library assumed this, many of its methods would not work. You know what I'm trying to say? So from your perspective, as a programmer, you write a foolproof class. You do it. Don't worry about how and who will use it. You can't impose rules on others. If you do your job well, you don't have to worry about it. So you'll say, who will send a negative amount? Doesn't make sense. Why doesn't the tester test it? Logically, yes, it could test it. I could do it there. I could say, before you call this method, ask the user, and there in a while loop, do not, force the user to give a positive value. But are you writing the tester? No, who knows? So you make your job, even if the tester does it. Maybe we do it in the tester also. Even if the tester does it, if I would write a tester, I would always check values, validate them before sending it to a class. But that doesn't mean that everybody will do it. Everybody makes mistake, right? I could use the character at method of the string class by giving an invalid value. The string class did not assume that anybody who uses the string class exactly knows that the value should be within the bounds 0 to whatever length, -1. If it had assumed that, then it would not be successful, right? So that's exactly what I want from you. When you write your code, whatever you write, and I'll give you good code when I tell you to work on it. But whenever you write code, you take care that everything that you do is foolproof. So now it is foolproof now. So you are saying if it is less than or equal to 0, the amount to be stocked cannot be less than or equal to 0, else stock it. Work done. I don't have to do any other checking. Now, if I had a maximum quantity, then I would have to check that I cannot stock if the get quantity plus amount becomes greater than maximum quantity. And you'll say, how will that do it? The set quantity when called will have an extra condition. The quantity should be less than maximum quantity, less than equal to. So if you try to go beyond it, that method will throw an exception and this method will throw an exception. All you have to do is take care of each and every error or exception that can occur in your code. That's all you have to do. If you create a foolproof class, you don't have to bother how it is being used. Okay, then it will be used correctly. Okay, so that takes care of restock now. So I changed it from what I gave to you. Now I'm fine. I can call it with a negative amount, but if I call it with a negative amount, it will stop. If I call it with a positive amount, it will add it to the stop. Right? So now everything that you now write or we write in class, I'll try to throw exceptions and say, this is what we do. This is what we do. That will help you to kind of understand exceptions. I'll keep it simple. But of course, I could have created one exception class for every kind of exception you see, which is too complicated for such a simple class. Let's try to sell a product. Right? Again, why have I said throws exception here, though the method is not throwing anything? Because I'm using the set quantity, which is throwing. So that's a rule you have to remember. Okay, so change your Java doc comments here also, please. Return true, we'll redo this and we'll say it doesn't return anything and we'll say throws. My exception. When does it throw the exception? If amount is greater than, if amount is less than 0. And it knows what amount is. See, it can see this parameter. We only are talking about what the user can see. Notice in the Java doc comments, you can see these signatures. When you see the signatures and it talks about index, you know what it is talking about. That's why I use these names. I can use these names because it's right there in the signatures of the method. So change that Java doc comment. Okay, there is no return now. I removed it. I didn't want it. It was not necessary now. So we started with letting it stay at its default value. Then we started adding Boolean return types so that we could say something worked or did not work. And now we are at step 3. We've started throwing exceptions, which is how you should basically do it. Okay. Okay. Now let's look at the cell. The cell says if the get quantity is great, so cell has no parameters. So you're selling 1 unit of the product. It's an overloaded method. You will see you can sell more than 1 also. We'll come to it in a minute. The sell product method is selling 1 quantity, one unit of the product. It says get the quantity if it is greater than 0. You could have checked if it is equal to 1 or whatever. But I said, is it positive? Yes, it is positive. Subtract 1 from it and set it back and return it. Now in this case, there is no error. There is no input validation I can do. There is no input here in this method. I don't take anything from the user. So what do I validate? Nothing. You'll say, couldn't you throw an exception here if get quantity is greater than 0? Yeah, you could. Instead of setting or other way around, you can check if get quantity is less than 0. But the main thing is that get quantity will never be less than 0 because we're never letting it setting less than 0. So it's not that, let's throw exception everywhere. You know what I mean? Like the set method doesn't allow you to set a value less than 0. So how will get ever throw an exception? It will never. You will never have a quantity less than or equal to 0. This will never happen. It will. When I say greater than 0, I mean, do you have something? But if I've sold everything, I could have a 0. But that will again throw an exception. Quantity cannot be 0. So therefore, I don't do a check. You could. There is nothing wrong in it. You could, but it won't. It will work. It will work fine. So maybe, do you think we should allow 0 to be a valid value? We've said quantity cannot be less than equal to 0. So if I try to get a quantity and the quantity is greater than 0, so if it is 0, it will not work, which is okay. It should not work. I can sell something if I have a quantity equal to 0. Right? So this is okay. Get quantity must be greater than 0. But the only problem is,
Quantity can be 0 also.
Yeah, I'm thinking, suppose it was my last item in stock. If it was last item in stock, it will try to set it at 0. And that will throw an exception that you cannot sell. So maybe 0 is a valid value. You know what I mean? Like it's not wrong. It's just not logical. Like
We should also give exception that there's no product, no stock available for sale.
Yeah. So the quantity will be set to 0. But next time I try to sell it, I'll have a problem. So think, can quantity setting 0 to quantity, should it throw an exception or is it okay? Because it can happen here. And you won't be able to sell your last item if you do that.
You also told about the reorder one.
Yeah.
Minimum limit to the stock.
Yes.
So it's probably 0.
Yeah. Reorder cannot be 0. Reorder cannot be 0. Maximum quantity cannot be 0. But quantity is a value that can be 0. You know what I mean? I have the last item and I sell it. I should be able to sell it if I even have 1 item. I should be. Yeah, but see, this will cause a problem. If this is the last item in stock, get quantity is greater than 0, yes. But what will get quantity minus 1 do? Make it 0. When I try to set it at 0, it will throw an exception. So I won't be able to sell my last item. So I think we should allow the quantity 0 as a valid value. You see what I'm trying to say? Unless there is a rule, no, quantity cannot be 0, then we'll do it. But otherwise, logically, if I have 1 product in inventory, I should be able to sell it. Like, why am I stopping myself selling? Before that, definitely a report has been taken out that it needs reorder and it isn't reordered. That's something else. But otherwise, selling the last item, now I'm okay. So I'm removing the equal to 0 as not as an exception condition.
Actually, already allowing quantity to be 0.
Now I'm allowing it. I had an equal to sign here. In that case, I was throwing an exception.
There wasn't equal to
In your product, there wasn't? Okay, I did it when I just wrote it right now. Okay, you didn't have it. Okay, so there. So quantity can be 0. I just am doing it. I just did it 5 minutes back or whatever. Okay, so why did I do this? I said quantity, price we won't allow to be 0. That's ridiculous, right? So this will keep as this. You can't make price as 0. But quantity I'm allowing to be 0 because I should be able to sell my last product if there is only 1 in stock. If I don't allow that, then my sell method will not work properly. If you have 1, you should still sell it. You don't say, oh, this is my last one, I won't sell it. You know what I mean? So we'll do that. So quantity is less than 0. I've changed. If you didn't, that's fine. I did a less than equal to 0 in my class, in my method. Okay, so now does it look okay? If you have greater than 0, get it and return true. Then
now there could be another exception that if already the quantity is 0.
Or what will happen in that case? Think about it. When if I try to sell something and the quantity is 0, this will not do anything. It will return a false. Yeah, you could say if get quantity is equal to 0. You could throw an exception. Yep, you could do that. Nothing big at all.
You will already throw an exception. It will be negative value.
Oh, yes. Yes, it will. So either do it yourself. You can put an if yourself if you want to be like check everything, or this set quantity will throw an exception anyway. So if you've sold your last item, now the quantity becomes 0. If you try to sell another one, this will not happen at all. Oh, so no exception will be thrown because it goes into this only if it is greater than 0. So it will just return a false. So let's do this. Maybe it's a better one. If your quantity, if you use your gets too many times, it's always a good idea to put it in a local variable, is equal to 0. Throw an exception. Yeah, that could be another idea. No item in no, product not in stock. Cannot sell. Yep. Yeah, not bad. That way it won't even go to the other if. Okay, so now do we need to do this? We don't need to do this now if get quantity is greater than 0. Now this becomes redundant. It can never be less than 0. I've already checked for equal to 0. I could have said less than equal to, but kind of looks like cannot happen ever. It can be less. We never let it be less than 0. So putting that condition is not incorrect, but logically doesn't look right, right? So do we now need this if? I don't think we need this if at all now, because if it is not equal to 0, it is definitely greater than 0. Now you can remove this. So improve it, however you want it. Now actually we don't want to even say return true or false. We can make it void. You see, like you can improve, you can do whatever, you can make changes if you want. Here. Here. Every method can be written in a different way now. So let's throw it. Takes no parameter, throws my exception if there is no product in stock, which is logical. How can you sell something if you don't have it in stock? Right, so that product class was given to you to make changes. We are making changes, right? It was not a final class. That's what we are trying to learn. How to improve the class by throwing exceptions. We'll do one last one and then we are done for today, okay? And it is the last one. So this is the class that you will need to complete in the in-class next week. And this is the class on which your retest will be based. You will be creating a stock, an inventory of these products. So understanding this class is important. Okay, we will write the tester, of course, but not today. We can't write it today. Okay, this method sells some items of the product. So that sum is coming here. How many? We don't know. Okay, so let's try to do our own things again. We can do this now. The first thing we can check is if amount is, what about less equal to 0? That's also an exception. How can you sell a particular 0 amount? You know what I mean? Okay, so let's throw. So let's improve this one also. Okay. What do you want to say? Amount to be sold cannot be negative or 0. Or shall we say amount or shall we say quantity? Yeah, it's kind of quantity. It's not an amount. But if I start saying quantity, I hope it doesn't mean something else. Some programmers think 0 is not an invalid value, it's just a useless value. So you could say less than 0 and I'll still sell 0, but kind of doesn't make sense to me. Notice how here I used a local variable because I had to use it more than once. So instead of saying get quantity many number of times, I just put it in a local variable once and then I say, so this amount greater than 0 is now not needed at all. So if it is less than 0, my job is done. Oh, we can create a, okay, let's create a throw my exception. Okay, what else is a problem? If the quantity that you get, you can't sell if this get quantity is less than the amount. You can't sell it, right? How can you sell something if you don't have it in stock? So again, you can say throw new exception. Oh, what did I do? What should you throw? What message? Not enough in product, not enough in stock or something. What did we say in the previous one? Product not in stock. Not enough of product in stock. Let's say it this way. You can even show how many are in stock if you want to. I mean, nothing stops you. You can say not enough of product in stock. There are only, and show the value of get quantity. That could be a better message. You know what I mean? So that the user knows what's going on. So you can make your exception messages as meaningful and resourceful as you want. Okay, so that's taken care of too. So now I can remove this if statement altogether. Else set it. And we don't have to return true or false. Delete it. And we'll do a throws. Throws a my exception. If not enough in stock. Oh, why is it giving me an error? This method must, oh, Boolean. Oh, forgot to change the void. There it is. Again, see, I've taken care of every error condition that can occur. Amount cannot be less than or equal to 0. How can you sell negative amounts? You cannot sell if your get quantity is less than the amount because there's not enough in stock. And if you wanted to show, you can add there are only and find out that get value and just add it. It's not a big deal at all. Now my product class looks to be foolproof. Maybe we'll find something else when we write the tester, but I think every method that we've written is doing something. So sell product, restock, everything is throwing an exception. So hopefully we can't go wrong. When you start checking it, when you start testing it, then things change, right? So we'll stop here. I'll put this back on Blackboard for you, and we'll continue to work on this next week. Maybe half hour for the tester, and then you're in class. Okay, we'll need half hour for the tester when you start testing. Or maybe I'll make it ready, and that way we can save time. I'll do that, okay? I can do that. I can put this back on Blackboard for you. So your class examples, Thursday. So there is already a product and so on. So these are, do you think I can just remove this if that's okay? Because this is, you've already picked it up, right? So let's overwrite it with today's class. So this is not midterm. Okay, so your Thursday. Where is your, there it is, product and stock. And we just changed the product. I think my exception remains the same. I don't think I did. And tester will remove. I'll just, I can't do anything. Okay. Anyway, the tester is incomplete. I don't think my exception needs to be overwritten. I don't think I made any changes. It's same as, yeah. Okay, so the old product is gone now, guys, okay? Tester we'll write next week. Maybe I'll put it here and we'll discuss it, okay? So revise. And again, array list is, again, your retest is all array lists. 10 methods maybe. That's it, okay? So if you want to do well, revise, and keep meeting me or seeing me if you want.
So next week will be the retest?
No, next week will be an in-class. 2 weeks from now will be the retest. Because I want to finish this off before you do the retest. Because the retest will be based on the product class. Okay? Thanks.